Hey everyone. So I wanted to show today a couple of new example applications or new JavaScript frameworks that are currently available and that are enabled by the new version of the Spin 2.0 SDK for JavaScript. So I'm going to just jump right into the screen here and start showing you what's going on. So if I switch over to here, excuse me, inside of the Spin JavaScript SDK repository, there are new two pull requests for adding an example that is written in Vue.js and then another one in Nuxt.js. Now, people who might be familiar with JavaScript framework SDKs, they will probably be familiar with these two JavaScript frameworks. Vue being the kind of like a client side. It can also do some routing in there, but it's kind of like a bare bones JavaScript framework for writing components in Vue. And so the documentation is all available online and stuff like that. But what's really cool about this is under the hood of Vue and Nuxt, Nuxt is the framework around Vue. So it provides a little bit more of server-side components like routing and how you do page layouts and things of that nature, and writing an API as well. And there's documentation for all those different things available in there. But what's really cool about these two frameworks is that they can be rendered server-side or client-side, but also as part of the framework itself, they have tooling around how to build these projects. So inside of the documentation, if you go and look inside here, there is an application called Nitro. And if we go Nitro, let's go Vue and search for that. The server engine. So Nuxt and Vue has introduced this project called Nitro, and Nitro is basically the way in which Vue.js and Nuxt.js applications are compiled to whatever target they are. Now, this can normally be compiled to a Node.js server to run on that application. It can also be compiled to like Cloudflare pages or to other places like serverless environments. But it also turns out that it is possible for it to be compiled into an environment in which it doesn't require a node environment, and that can be utilized by the JavaScript SDK to then eventually be compiled into WebAssembly. So what do I mean by that? If I go into the project, I'll just show the Nuxt.js example because it's more of like a superset of Vue itself. So if I go into VS Code and show this, this is the source code for that Nuxt app, and what you'll see is that it's pretty much the exact same thing as what you'd expect in a Nuxt.js application. You get your pages, you get your public output, your server output, or anything that you want to put in there. And the index page just shows a welcome page at the end of it. And the only thing that we've introduced here to kind of show this proof of concept is how we compile it to WebAssembly so that it can be used and consumed by the Spin SDK. And so how that's done in Nitro, Nitro has a configuration file which can also be called inside of Nuxt config, called the preset. And a preset is basically how you want to compile the application or how you want to be able to precede it with certain configuration. And so the Nitro configuration itself extends certain functionality like a base worker, which is kind of like a generic Cloudflare pages or worker SDK. So it's not meant to run in a Node.js environment. It's meant to run as like a bare ESM module. So you can see the output format is an ESM. So Nitro takes this file, this configuration, as well as the spin.ts file to expose certain concepts that are inside of the compiled application, and then we can go and use that inside of the Spin runtime. So if I go into here and if I open up the terminal, and if I do, I've already done an npm install, but if I do an npm run build, what happens is that it still uses all the standard tooling for doing Nuxt things, like Nuxt build. You could do Nuxt dev if you wanted to, because this is it's just like a compiler target, really. So we could do things like that and show our application if I wanted to do Nuxt dev. npm run dev. In order to show that there. If I opened up to localhost port 3000, you would see welcome to Nuxt, and you get that hello page that shows up when you first create a Nuxt application. Now, that's just like basic compiling and making a Nuxt application running. Now, how do we get this into the Spin runtime? So I've added a build target called componentize, and what it does is it takes the output of Nuxt build, which gets thrown into this .output folder, and then there's this server. This then takes that, it's the input of the spin.js file, which is over here, or spin.ts, because it gets compiled by Webpack as the first thing in that step. Webpack mode production, it compiles the spin.ts into spin.js. So this is your Spin runtime application. It takes a handler, and then it makes a call with the Nitro application, which is just a way of being able to get into the handlers of the Nuxt.js application and pass in the URL that was passed in through the request. And then we can take things like logging the response if we wanted to. We can then set the response of the actual response that we're giving back from the Spin runtime. And then we can do things like setting headers based on what's available inside of the response body, and then actually sending the response body as the end of it. So this is a basic Spin application, but it's now taking and utilizing the output of the server-side rendered Nitro application, or Nuxt.js application. And then I don't have to go into the Webpack configuration, but after that has been compiled to JavaScript, it then uses this binary that is available from the FERMYON Spin SDK called J2W, which is a wrapper around the componentized JS project, and to make it possible for you to take the input of a JavaScript file and then write it out to a WebAssembly module. So if I do an npm run componentize, you'll see that it takes a very short amount of time. It then compiles it via Webpack, and then after that, it takes the spin.js file and spits out a .wasm file in the output. Now, the Spin project, or the spin.toml here, it now then sees, or it's now going to go and take that application, which is under here, the component.app is taking the output app wasm. And then there are some other things as well. We want to be able to expose any assets. So in this case, we want to take the client-side assets that are going to be available to the user, which would be the favicon, which we're exposing here. And then inside of Nuxt, there's all the client-side JavaScript. So what happens is that you have the server-side rendered and the Spin runtime going and using that and rendering it to the browser. And then the JavaScript on the client side then goes and renders the actual content as based on Nuxt itself. So how this looks and runs in practice is if I do a spin up of this project, and I think I have this little bug that happens inside of my thing. So if I do a Rust, this seems to work around the problem right now. If I go Rust log equals to debug and then spin up, I get a whole bunch of crane lift dumped out to the terminal. But eventually when this spits out all of the stuff and it's all done, then it's going to show that it's listening. It's taking a little bit longer than I wanted it to, but here we go. Okay. So now we can see that we have the available browser, the favicon, the Nuxt assets, and the app. So if I go open the browser here, you can still see that we have the Hello World page. Well, what's happening in the background is because this is a server-side rendered application, this isn't really going to show it too well because we're seeing the client rendering out the content that the browser does. But if we do a curl localhost 3000, this is what we get from the client. And this is just a whole bunch of minified CSS classes that are being rendered out by Nuxt itself, but you'll notice here that this is all being rendered by the server, the Spin server itself. And we didn't have to specify all this because what's happening is that that is happening inside of this spin.ts file here, is that this app response is being rendered back out to the client. And if we see here, inside of the console logs, that is exactly what is being rendered out by the application. And then we are sending that back as part of the body. So that is the example application that I wanted to show today. It's just the JavaScript SDK with various different frameworks, but it's very exciting because it's using server-side rendering as opposed to client-side rendering and then just putting it in a static file system server and then serving that up as a Spin application. This actually has some implications where you can go and take advantage of things like key value or SQLite databases or anything else that's available inside of the Spin runtime at server-side. So very cool stuff, and I just wanted to show that today.